Okay, this is lesson 6.4, transformations of trigonometric functions. There's two strategies we can use to graph transform functions. We can graph them by using the period, amplitude, horizontal and vertical shifts, or we can graph them by using mapping notation. And the strategy we used successfully last year was to use mapping notation to take those key features from your transformed equation, a, k, c, and d, and apply them to your x and y values for the parent function, in this case sine. So our parent function sine has these 5 key points, and the 5 key points occur when sine is at 0, its maximum 1, back to 0, -1, its minimum, or 0 again. And at those angle measurements that give you those values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if we remember them in degrees, that's 0, 90, 180, 270, and 360. So what we need to be able to do is to pick out a, k, c, and d and apply them to your x and y values, or in this case, your angles theta and your y values. So where is a? Well, a is right in front of sine. K is factored from inside the function, and remember, you must common factor. So if there's a value in front of theta and it's not next to a bracket, we need to common factor that value out first from both theta and whatever value is being added or subtracted to theta. Once we've common factored, that's your k, and what's left over inside is your d, kind of. We need to take that value, negative pi over 6, change the sign to actually get d, because in the parent function, the transformed function, we have a negative d. C is the value on the end. So that's, there's d, and c is the value on the end. And if we can apply a, k, c, and d to our original x and y, we can come up with new points for our transform function. So x is our theta in this case. So it's theta divided by k plus d. K is 3, so it's theta divided by 3, plus d, which is pi over 6. Ay plus c, a is -3, so it's -3y, plus c is +1. And then we take our x values, plug them in, and transform them. So let's try to do this really quickly. You should probably do it in your calculator. That would be the most efficient method to do it, just plugging in your values for theta, dividing by 3, and then adding pi over 6. And if you have a calculator that works with fractions, using the fractions button to do this process will probably be the easiest way to do it. But I'm going to mental math it out here because I don't have a calculator handy. So 0 divided by 3 is 0, plus pi over 6 is pi over 6. Pi over 2 divided by 3 is pi over 6, plus pi over 6 is pi over 3. Pi divided by 3 is pi over 3, plus pi over 6 is pi over 2. 3 pi over 2 divided by 3 is 3 pi over 6, plus pi over 6 is 4 pi over 6, and if we reduce that fraction, we get 2 pi over 3. And our last one, 2 pi divided by 3 is 2 pi over 3, which is the same as 4 pi over 6, plus pi over 6 gives us 5 pi over 6. There we have our x's. The x's are the most difficult ones to transform. The y's are much easier because you don't have to deal with pi, you just whole numbers. 0 times -3 plus 1 is 1. 1 times -3 is -3 plus 1 is -2. 0 we've already done is 1, so that means our last one is also going to be 1 because it was 0. And then -1 times -3 is 3 plus 1 is 4. So there we have our y values. And now we just take our x and y values and plot them on our graph. So let's do that. Got a nice scale there, which conveniently actually has our pi over 3 and our 2 pi over 3 on it. Between pi over 3 and 2 pi over 3 is pi over 2, and it's directly in the middle, so I'm going to put it directly in the middle here, pi over 2. And pi over 6 is directly in the middle of 0 and pi over 3, so that one would be there. And that means our 5 pi over 6 would be directly in the middle here. All right, there's our x scale, and now we just got to plot our y's. Pi over 6 and 1, so that's a point here. 3 pi, or pi over 3 and -2. That's a point down here. Pi over 2 and 1, point here. 2 pi over 3 and 4, that's a point up here. And 5 pi over 6 and 1. That's a point here. And if we connect them with a nice smooth curve, we get a function that looks like this. And if we continue it just a little bit, we can show that the function continues. And this is our y equals -3 sine 3 times theta minus pi over 6 plus 1. So mapping notation to get our values. What about this amplitude, period, and reflection, horizontal and vertical shift? Well, you can use that to check to see if we graphed our function correctly. The amplitude, where's the amplitude in an equation? Well, the amplitude comes conveniently from A for amplitude, and it's the number, but sign independent. So the amplitude is just that number, 3. And on a graph, the amplitude comes from the axis to a max or the axis to a min. Well, what's the axis? The axis is actually your vertical shift. So amplitude comes from A, vertical shift comes from C. Your vertical shift is +1, or that in this case is up 1. C gives you your axis. Our axis in this case, because we're shifted up 1, is y equals 1. That's our axis. So our axis on our graph is actually y equals 1, and if we draw that horizontal line, there's our axis. Our amplitude is from the axis to the min. And what's that distance? Well, that distance is from from +1 to -2. That's 3 units. And from 1 to 4, that's also 3 units. So there's your amplitude. Up 3 from the axis or down 3 from the axis to get to your min. Up to get to your max. Reflection? Reflection comes from this value, or that sign right at the beginning. Anytime there's a sign in front of A or K that's not positive, leads to a vertical or horizontal reflection. In this case, since it's on A acts on Y, so that makes it a vertical reflection. And a vertical reflection would be a reflection over the x-axis. So that also comes from A. The period comes from K, and the period, there's a little mini equation up here, is 2 pi, which is the period of the original sine function, divided by K, which is your your horizontal compression factor. So in this case, it's 2 pi divided by 3. So that means we complete 1 cycle every 2 pi over 3 units. And we can check that on our graph too, because here between pi over 6 and 5 pi over 6, we complete 1 period, which is 2 pi over 3. And to confirm that, you can do a little bit of math. Would be 5 pi over 6, subtract pi over 6 where we started, and that would be 4 pi over 6, which is 2 pi over 3. Get that off there. And our last piece is the horizontal shift, or the shift left-right. The shift left-right is your D value, and our D value in this case was pi over 6, and since it's positive, that's pi over 6 to the right. And our starting point for sine originally was 0, 0, so starting on the y-axis at 0, we're just shifting that first point to the right. And you can see that it's reflected because usually sine goes up. In this case, it's going down first. So that's how you can use all your key properties to confirm that you have your graph correct. And it's important to be able to take the key properties out of the equation, just as it is important for you to be able to take A, K, C, and D out of the equation to write your mapping notation to graph it. Do you have to do this analysis after you graph every time? Absolutely not. But it's a nice way for you to check. That's it for lesson 6.4. I'll see you in lesson 6.5.